Hello everyone, I'm Mehmet Alkuş. In this video, we will solve one problem in Chapter 9. A block of mass m 450 grams is released from rest from a height of 8 meters. The block strikes the soft earth and holds within 0.021 seconds. A. Find in unit vector notation the impulse exerted by the earth on the block. The momentum impulse theorem states that J, the impulse exerted by the earth on the block, equals the change in the momentum of the block. That is, momentum after the collision minus momentum before the collision. Since momentum has the formula mass times velocity, we have mass of the block times the velocity of the block after the collision minus the velocity of the block before the collision. Because the block halts after the collision, that is, stops, its velocity after the collision is 0. Therefore, the impulse exerted by the earth on the block is negative m times Vb. Now, the conservation of mechanical energy states that initial mechanical energy of the block is equal to the final mechanical energy of the block. E1 is the energy at position 1 and E2 is the energy just before hitting the ground. Namely, the sum of the initial potential and kinetic energies of the block equals the sum of the final potential and kinetic energies of the block. If we choose the bottom level as the zero gravitational potential energy level, we obtain at position 1 as m times g times h for the potential energy of the block. The initial kinetic energy at position 1 is 1 over 2 times m times v0 squared, and since the initial velocity is 0, then we obtain 0 initial kinetic energy. The gravitational potential energy of the block at point 2, that is at the bottom, is 0. Then the kinetic energy of the block at position 2, that is just before the collision, is 1/2 m times Vb squared. Therefore, we obtain the conservation of mechanical energy for positions 1 and 2 as m times g times h equals 1/2 m times Vb squared. M's are cancelled, so we obtain the speed just before the collision as square root of 2 g times h. And since this velocity points the negative y direction, we have vector Vb as square root of 2 times g times h negative j hat, or negative square root of 2 times g times h j hat. Now, if we put this velocity in equation 1 for the impulse exerted by the earth on the block, so we obtain the impulse as m times square root of 2 times g times h j hat. Now we substitute the numerical values into this equation. So we obtain the impulse exerted by the earth on the block as 5.6349 j hat Newton seconds. Or in three significant figures, it is approximately 5.63 j hat Newton seconds. As you see, the impulse exerted by the earth on the block points the positive y direction. B. Find in unit vector notation the average force exerted by the earth on the block. According to the definition of impulse, we have J equals average force times delta T. From this, we obtain a formula for the average force as J over delta T. Substitute the numerical values into this formula. Here the units of seconds are cancelled. Therefore, we obtain the average force exerted by the earth on the block as approximately 2680 j newtons. As you see, the direction is from the earth to the block. Okay, this is the end of the discussion of this problem. Thank you for your attention. See you in the next video.